Okay folks, what we're going to look at here is just the example we ended last class with. Asked that this be completed for homework, so just review it and make sure everyone has it done right. So in the example, you were told that a tow truck is lifting a car and towing it. When it does so, it makes an angle 60 degrees with the horizontal. So I'll just grab my pen here. So you think the tow truck is pulling the car. It exerts a force of 3,100 newtons to lift that car. And when it lifts the car, it makes an angle 60 degrees to the ground. And what they're asking you, what are the vertical and horizontal components of that force? So how much of the force is going vertical? And how much of this force is horizontal? So two formulas you were told last class to figure out the horizontal component. Force horizontal, or on the x-axis, is the force that's being applied times cosine of the angle. So the force that's being applied, you were told, is 3,100 newtons. And cosine of 60 degrees. So you should get an answer of 1,530 newtons. And for the vertical component, force applied, sine of theta, so 3,100 newtons times sine of 60, so 2,685 newtons. Okay, so the last example I want you to take a look at. So try these two examples first, then replay the video and see if you got them right. And if you have any questions, you can ask me in class. So for example 3a, a force of 120 newtons is applied at an angle of 32 degrees east of north. Or another way, describing the same angle, is north 32 degrees east. Find the x and y components. You're given a caution here. Be careful, watch the angles. There's a reminder I'll give you. You may have forgotten this from trigonometry. So when you're finding sine and cosine of an angle, that angle, you're always referring back to the angle that's closest to the x-axis. So if you were asked here, if I gave you this situation, so this is 32 degrees, the angle that you need is not to find the x and y components. You need to know the angle that's closest to the x-axis, not this angle here. And what you would do in this case is that the angle between x and y is always 90 degrees. So if this is 32, then the angle inside here must be 58 to make up the 90 degrees. Now you were asked to sketch, you should do a sketch of 32 degrees east of north. So you're setting that up. North is here. It's also our y-axis. So you're heading 32 degrees east of north. So you're heading north and going 32 degrees east. Another way to describe the same angle is that you're heading north 32 degrees east. So you should have a sketch done when you're doing this, because it'll help you set up your angles correctly. Because the angle that you need, as I just said, is not the 32 degrees. You need the angle that's closest to the x-axis, this one here. And that, as we just said, is 58 degrees. So now when we want to find the x and y components, your applied force, sometimes it's written force applied, times cosine theta, so 120 times cosine 58. And that works out to 45 newtons. And your y component, so your force applied times, sine of the angle, so 120 sine 58 will give you 111 newtons. So in this example, you're asked to watch the angles, and the next one below, watch the sines. I'll just bring it back to a previous slide. What you need to remember is that if you're in this quadrant here, both your x force and y component of the force are positive. Then here, x is positive, y is negative. Here they're both negative. Here x is negative and y is positive. So you need to remember that. So force of 550 newtons is applied at an angle of 25 degrees south of west, or describing the same angle as west 25 degrees south. So heading west, it's not completely west because you're going 25 degrees south. Now this angle is the angle that's closest to the x-axis. So we have the proper angle that we need. If you can go from your applied force, draw straight to the x-axis, and the angle you need is listed there, that's what you want. So this force is 550 newtons. So you're asked to find the x component of the force. So how much of the force is going on the x-axis here, and how much of the force is going along the y-axis. You know now that's the applied force times cosine of the angle. So the applied force is 550 newtons. Cosine of 25 degrees. Now you're not finished here. The force is down here in this quadrant, and you're told that x and y are both negative here. So your answer is negative 498 newtons. So you need to check the quadrant you're in. And the y component is your applied force times sine of the angle. It's 232 newtons. And again, your y component is also negative down here.